Okay. Right. That's good. This is a delay. Okay. Is it showing up there on that? Great. Sorry for the delay, folks. We had a few technical issues. It is raining here in Dubai, so we've had a few internet issues as well as some streaming issues, but we're all sorted out now. Unfortunately, we've not got it on Facebook Live at the moment and on the Periscope, but our YouTube stream is going to come through fine. So, happy Arduino Day. It's Arduino's 15th birthday, March 21st. We didn't want to miss it. We did have a big live event planned, and we were all ready to go with a big, live show with attendees and a whole program that would run all day. But unfortunately, due to the COVID situation, we have had to adjust our plans a bit. What we are doing here instead is not the full show that we were planning, but because we are only going to encapsulate it in 2 hours, we are running a bit late, so it is going to run a little bit longer. So maybe we should wind up by about 1:30 Dubai time. Of course, we will keep our question and answer sessions going. We'll give you some more details on that. At this point, I do want to also mention, of course, Arduino is an Italian company. Thank you to Arduino for supporting us this year. We've done Arduino Day before, but this is the maximum support we've had from Arduino, and we're very keen to make sure that, that we do a good job with this. Unfortunately, we have a little bit delay, but we will now carry on as scheduled in the original plan. Okay, so like I said, our thoughts go out to the Italian people, of course, because COVID is a tough situation, but especially for them, and we're very grateful, and we are, like I said, we do have a lot of support. Speaking of Italy, we do have our very own maker from Italy here. This is Simone Majocchi, who has moved from Milan to Dubai. He's now a Dubai resident, so I shouldn't call him an Italian maker, he's now a Dubai maker. And he's a man who wears many different hats. He's a tech journalist, a pioneering tech journalist. He's a maker, an interaction designer. He's a 3D printing expert who's written books on the topic. So this is the man you want to go to for all that. But more key to this, he's blushing right now. More key to this is that he is actually a member of the global Arduino team. So he works with Arduino, working on the website, the projects that go on there, the live content, a lot of stuff, a lot of different things. I'll let him explain his role more. I'm sure I'm not doing it justice. So yeah, Simone is going to be leading the show, and he's going to be doing most of this, most of the presenting here. We are, of course, one thing that we did tell you is that we are going to be giving away a lot of swag throughout the thing, but we're going to make you work for it. There is going to be a quiz and questions, and you have to keep interacting. Unfortunately, that's only open to Dubai, UAE residents, so because you do have to get it physically. I'll just give you a quick sample. This is what we've got on hand. We've got official Arduino t-shirts that we got from Italy a long time back when we were preparing. And we've also got some Arduino hoodies, and we'll also throw in a few Arduino pens and stickers, so you're going to have a look at that. Let's have a quick look at our agenda before I hand it over to some stuff that is very interesting to you. I think I can hand it over. Simone, can you take over now? Maybe you can explain the swag giveaway. I'll just bring up the slide.
Okay. Well, thank you. First of all, thank you very much to the Assembly for hosting the Arduino Day 2020. It's tough times for everybody, but we are really trying our best to make out of this different situation the best out of it. Going back to swag, okay, Arduino is launching a certification program. So what we thought was, why don't we give it to our community a hint on how it's going to be this certification program? So throughout the day, throughout this live show, we will be showing you a slide in between every segment, and each of these slides contains a quiz with 4 possible answers. What you should do is you should send an email, and the email is to ad20@theassembly.ae, and you should put in the subject the number of the question, and in the body your answer that can be A, B, C or D. In every slide you will find this information, and the one that is the fastest one to send in the proper answer will get the swag. So there will be many occasions to get some swag from us. and we hope that you will enjoy also the kind of questions you'll find. So it's a challenge for you. Stay tuned, keep looking at the stream, and you'll find out those questions rolling into every single segment.
Okay, hold on, we're going to do the slide. We're putting on the scene.
Okay,
We're gonna do the quiz.
so it looks like is audio coming out? You see, everything will be fixed in minutes, but you know, we are tuning in and we have to do things. Is audio coming out?
Yeah, audio is up now.
Audio is up now. So we have been doing everything without audio up to now.
No, only on this one with the slides.
Okay, only this one with the slides. Perfect. So let me get back, and if I can check where we are with the slides, could be nice. So
That's not there.
that's the swag giveaway. And okay, we are switching to the
Can we increase it?
two-day slide. Sorry guys, just fixing things. It should be okay in a few seconds. If I'm looking that side, because you can guess that there is people on my right side that is sweating and pushing on keys, and this is again the beauty of having to set up everything in such a short time with live stuff. Okay, so they're telling me we've got the slides, we've got the audio, and I can go back to the situation. So if you can make it set so that we can see both, fine. Okay, Arduino philosophy, open source, and makers movement. Let me get back to this part. Hopefully everybody is now able to listen to me. I've got people just going below tables. Okay, I'm right to go. If someone happens that is really unpredicted, bear with us. Okay, today, as I was saying, you know, we've got a lot of stuff going on, so we can switch to the next slide so that I can show you in reality what's okay. So you see, this slide has a thing that is highlighted that is 104 million projects. Those are the projects available probably a couple of weeks ago on the internet that were Arduino themed. So I did a search Arduino project, and this is the power of open source. It means that every single project of those 104 millions is available to anyone to download, to make, to modify, and to make its own. So basically today we are living in a situation where anyone can make almost anything out of technology, and when I say technology, I really mean technology. It can be any kind of thing.
You can carry on. This is just going back for 1 second.
Okay. For instance, this is a piece of technology. I don't know if you can see that. So if it's something that is going to be some sort of live stream, but this is a thing. This is a design I made starting from an open source project, and there is some electronics behind. Let me see if they can switch me online on top of the slides. Yeah. In time we'll get better. I'm pretty sure that we'll learn how to
You're back on the
tame. So I'm live, and so I'm also showing stuff. People can see the stuff I'm holding. Okay. So basically as was...
So just give us a signal when you want to go back to the presentation.
Yes, I'll give you a signal. I'll do some kind of signs. So okay, you know, negotiating with the team how to manage this stuff, and again, it's going to be better and better by the time we do it. And at the end of today, we will be very, very good at that, and next time it will be even better. Anyway, so I was saying this is a piece of hardware I made, and this is basically something that allows me to send on a Google Sheet what I'm doing currently in terms of project. So it's a timesheet device, it's a timesheet tracker. So I move the slider and I get something on the display, and the display says you're doing that particular task, and it goes sent to the Arduino Google Sheet. This was a modification of a project that I found online, so it's not something I designed from scratch, but it's something I made basically to get my needs fulfilled, starting from something that was with a different kind of solution. Anyway, this was possible because there is open source. But let's go back to the slides and let's see basically how it all began. Okay, a long time ago, basically in 2005, the situation was slightly different. So, the slide should be the next one. Okay, let me see if they can switch. It's where it all began. going to work.
Okay,
Just one. The next one. Thank you. Okay, it's going to work in that way. Okay, it's a long time ago. There were a long time ago. Again, 2005. Let's put things in perspective. The electronics were more difficult, and basically it was quite hard to make circuits. So I can show you, for instance, an old circuit that I made. And basically we don't have the live feed from me. Yeah.
go back to that?
Well, yeah, we have to do some going back to my live thing. Yeah, it's going to be not properly shooting anyway. So can you get the live stream?
Display. Yeah, it's still on mute, but remove the display.
Okay. Right.
Okay.
I'm showing stuff, so
Yeah.
bear with me again. We are trying to fix things. You see this circuit. This is a handmade circuit that has something like 15 years, and it was based on a microcontroller, and this microcontroller was a PIC micro. I did all the wiring, and it took me something like 2 weeks to make this thing. And I had to use very, very complex tools to make the programming. I had to design my own hardware, and it was quite a complex process. I burnt a couple of microcontrollers because there was some magic smoke that came out because some wires were not properly wired, and was the way it worked in 2000 and 2002, 3, 4 up to 2005. But there was a person that somewhere was thinking, can we find out a better solution to make things easier? And this man, that is Massimo Banzi, the co-founder of Arduino with other people, had this idea in Ivrea to design a board that was able to make things easier. So basically what happened is that Massimo had a series of questions, and basically it provided the answer. So we can switch back to slides, and we can see the next slide that summarizes the situation. Click on the mouse, please. Go to the next slide.
Yeah.
The mouse is there. Click there. Thank you. Okay. Okay, those are the answers. Basically, if you give me that mouse, I can do it on my own. That's going to be better. So we are learning how to make things easier. So basically, you see, this is the situation. The answer to the problems that were here, that were the microcontroller being custom hardware, the programming that was very complex, and the prototyping that was a painful process. It became something with some answers made by Massimo, and I'm just lost with the mouse. I'll see it going there. Oh yeah. So I got the mouse here, but it's okay. Got it back. Clicking and seeing. Yeah. Okay. Moving.
Okay, let's do something.
Yeah. Yeah. Turning a little bit more.
Okay. So you want to go to
The next one and the next one again. So we can switch to the slide. Go to the slide with the Arduino board.
Okay.
Okay. You see that board? That board is the very first Arduino that was designed, and this design is still with the serial port, something that some of you might not know, and that connector that is now replaced by a USB is basically the serial connector with which it was possible to program the Arduino microcontroller. And that was the beginning, because it was not just that, it was the board. There was an IDE, that was an environment that allowed you to make programs and to write code that went directly into the microcontroller in a very efficient way. And also, because that board was manufactured by someone else and not you, that someone else granted you the working of that board. So the hardware was fully tested and it was properly assembled. So we knew, everybody knew, that when they had to turn some pin on, that pin was going on, and it was a big improvement. So in time, things changed. There were more boards. there were some other designs, and the whole thing became more or less, we could use the term viral, because something that everybody understands. So what happened? The design was given into the open. It was open source hardware. A number of companies picked that design, and it became slowly but steadily a success. So people started to use the Arduino, and it became some sort of platform that was shared by a number of design. So moving forward, if we can switch to the other slide, the next slide, we see that we now have many boards. You can see on the left the big Arduino Mega. Then in the middle we have the little Nano Sense. On the right we've got the Uno, and on the bottom we've got a Maker 1000. So those are completely different boards. Every one of these boards has allowed people to make different things, and those different things range from very simple devices to, and if we switch back to live, I can show you something interesting. Okay, this is heart of a modern 3D printer, and you probably can't see that, but in here there is an Arduino board that is embedded in this whole design. This is basically the brain of a WASP 3D printer, and it's open source, and it has become one of the best Italian 3D printers because it was developed on hardware that was possible to design internally by this company using the very sophisticated Arduino Due board. So this hosts an Arduino Due board inside and has got all the electronics to drive the rest. So this is an example of what you can do in terms of a product using an Arduino, and is an integration that is very interesting. Still, let's go back to the slides. These boards basically made the whole design process a new kind of technology, a new solution available to everybody. Next slide, and what happens is that sharing becomes an attitude. The attitude of making something, sharing it with someone else, letting the internet make wonders of our design, and just wait that the design comes back bettered by the brains of a lot of people that has used that, tried that. Also, making an initial project something completely different. One thing that you have to remember when you are a maker and you are prepared to share your designs is that you shouldn't do that if you can't accept that someone takes your design and makes something completely different out of that. You have to think that is not your child, it's something that you put in the open, and so you should be prepared that people does crazy stuff with your design. You shouldn't be worried about that. It will be his own life, so you have to let it go and let it grow into something that might be completely different. For instance, 3D printers are a very good example on how sharing allowed a lot of people and companies to also create some businesses. In the, I would say, the 2015, 2016, there was this explosion of 3D printers, homemade designs, kits, and those were all based on open source designs. There is the RepRap wiki, that is the place where you can find, I would say now, hundreds of different designs of different printers that are all based on basically the same hardware. That was a Arduino Mega board with some kind of electronics to let the board drive the motors, and the design have evolved into X, Y, Z, delta, different ways. The Z is fixed and the XY moves, other ways. So everyone had made interpretation. Currently, we do have a series of printers that are directly evolved from the initial design that was shared by Adrian Boyer, that is a professor of a university in England, that was the very first one to share its designs. Anyway, moving forward quickly, the maker movement is what came out of this evolution, and this sharing that has become an attitude has brought us in a number of different areas. If you look at this slide, you can see that we have got on the left a lot of software that is open source, and on the right we have got this open hardware symbol. Open hardware symbol is something you find in all the freely available designs, and the left series of packages of softwares is something that you probably use even without knowing about Linux, WordPress, MongoDB, and Inkscape. All these programs are all also Python, is things that are open source and are freely available. Moving forward, what's the next step? Well, with all these resources, the makers movement arrived and made an impact on our lives. Basically, maker movement means that we have places where the spirit of making is shared, and it becomes community. People is getting the confidence and is getting also the knowledge to start up their own projects and their own designs. We said about 3D printers, but we should also think about all the campaigns that have been run on places like Indiegogo or Kickstarter. A lot of those projects were made as prototypes, and people was asking the other people in the community, are you prepared to give some money to us to make our dream, that is this current prototype, into something that is a product? And so things developed, and everyone was feeling this power of designing their own stuff. So the maker movement, we can just have a few pictures here. So switching to the next slide, we can see how things go, and these are just few pictures from events of maker fairs. And as you can see, we go from very crowded, and crowded today is not the best thing to say, but is how it was going. So a lot of people showing off their ideas in maker fairs, kids going mad with a lot of interesting things that they were able to understand, to make, to play with. And also we can see on the top right picture this kind of helmet that is like a famous musical group helmet, and was made by a maker that just wanted to make a statement. So makers basically are people that do make stuff on their own, and they are prepared to share what they make. And this thing has basically brought, let's switch to the next slide, to the current situation where we are happy to say that we have got 15 years of Arduino, and these 15 years meant the birth of the Arduino ecosystem with millions of users, but also the birth of the culture of sharing, making on your own, finding peers that are able to help you. This is one of the very important things, and I think that today you'll hear from people that is doing, is part of our community, that people that has made projects and has made design, that finding a place where you're not considered a newbie, a person that is not aware, you're not a person that has already got some knowledge. For the community is perfect. You are always welcome. There is always someone that is less knowledgeable than you, and there is always someone that is more knowledgeable than you, but those people are prepared to learn, share, and let you get into this community in the best way possible. So the community of Arduino is a community that care. We say sharing is caring, and basically this is the whole thing. So last slide of this kind of presentation, I would like to conclude this segment saying that basically the knowledge is what makes the difference, and with Arduino anyone can try to build and make code, finding his attitudes and skills at his own pace. Please come here, come to the assembly, come here and make some experiments, participate to our workshops, and let us show that it's something that you can make, and it's something that you can easily learn. It's not important when you want to design something to understand fully how it works, but please design something thinking on what it should do. This is the basic essence of our philosophy. And with this, okay, going back to live, thank you for your time, and we are now going to move to the first interview. But first of all, we'll have the first quiz. Okay, so people, prepare your email, send the email to our email. You will see that in the slide itself, but let me remember you the the email ad20@theassembly.ae. So the first quiz is
The music's going to start.
online now. And here we go with another very interesting interview with one of the guys in the community of makers of Dubai. And we are going to speak with Rishabh that recently graduated from the GEMS Millennium of Sharjah. And please, Rishabh, tell us who you are when you met the Arduino. The screen is yours.
Sure. My name is Rishabh Java. I'm a 17-year-old, just graduated from high school student. And I like to make things. I've been doing it since I was 7. I started out with simple circuits that I had made, like a clap switch, things like that. And moved on to like Lego robots for quite a while until I was 13 and discovered the Arduino. So it was about 4 years ago when I learned about these amazing microcontrollers called Arduino. And that was through a friend who was slightly elder than me, and one day he'd seen this project on the internet and he had the parts for it, and he was like, dude, let's actually get together and make this. And I was like, okay, I've not worked with the board before, but let's try. And that's how I kind of got into it. And I started experimenting with small projects. And at my school we had this Arduino starter kit along with the book. So it was like I sat down one day and I tried all those 13 projects that are in the book. And that's when I got a bit comfortable with the IDE, with the board, and basics of the with all the basic electrical components. And then from then it's just been going online looking for random projects that I can work on, just to teach myself different aspects of the board, learning about the different boards, and the wondrous things I'd say that you can do with them. So um, yeah, I guess that's basically
Yes.
been how I started.
Okay, so basically you discovered the Arduino thanks to the internet and your friend. So you probably saw that recently we have reached the over 100 million projects available online. If you just type Arduino project, you get this amazing number. But I think that you're a kind of guy that is really looking for something special. So I'm pretty sure that you have something very special to show us, and please do.
Oh, sure. So it was about, I'd say 3 years ago, I started working with 3D printing and decided to put Arduino and 3D printing together. So the first such project that I worked on was the prosthetic arm. That was a 3D printed bionic arm as a replacement for people that do not have their forearm. And normal prosthetics can cost a ton of money. And this was just like a $30 replacement to them, powered by the Arduino. So you have 2 servos that were controlled using voice commands using Bluetooth and your mobile phone, or directly connecting it to electroencephalography and using your brain waves to control the arm. So those are two methods of control. I'm currently trying to implement this project. I'm having an orthopedic in India tested. So that's one of the actual applications that I'm trying to actually put out there with the Arduino. After that, I think about 2 years ago, I started work on this. I call him Ferb. I call him Ferb. He is based on an open source project called InMove. It's a very famous project in the maker community where it's literally a 6 feet tall humanoid robot that's completely 3D printed, and it's all powered by Arduino, all parts of it. And I decided to start working on a very ambitious project. I never thought I'd complete it, but starting in May or June of 2017, I spent an entire year building two or three different versions of it until the final version. Like his head is on the table, the rest of him is lying in my room. But he's built pretty well, and yeah, I think that robot itself, it has like two Arduino Mega boards controlling the arms, and then they work well with the PC, which has the software for the cameras and all of that. So I spent a lot of time working on the humanoid, and then I wanted to work with mind control again. And I started hacking normal toys such as drones and normal train tracks to make them mind controlled. So I'd get these. I got these random EEG headsets on eBay. These were like, I got them for like $11, and then I had to modify them a little bit to get them to work with my computer. And I would get normal Chinese toys like drones or like remote control cars, and then and then add the Arduino element to it to either control a relay or act like an electronic switch, and use that to control the toys using brainwaves. So those are some of the interesting projects that I've worked on with the Arduino microcontroller.
Okay, yes, well, so it looks, yeah, really like the kind of user and person in the community that we really love to have, because you have all the elements. You are ingenious, you are creative, you are looking around and finding interesting projects to do. The robot was an amazing achievement because it took really a lot of time to build that kind of thing. And I'm really proud of you as a community member here in Dubai. I think that Dubai can count on you for a very, very good project that you will show us in the next coming months and years. So thank you very much for being with us and showing us your project. I hope you.
Thanks a lot for having me.
My pleasure.
Thank you. Thanks a lot.
Thank you. See you.
Great talking to you.
Hi, I am Rahul Kumar. I am the manager of the assembly lab. So since we've worked on a lot of different projects, Arduino has helped us out a lot in these kind of fields. In a kind of way, it's really good to prototype, do a simpler version, a bare bone version of the project that we wanted to do, similar to what we did with the 3D POV. We've done a 2D POV for a workshop a few years ago, and that kind of brought the 3D POV into fruition. Our original idea of the 2D POV consisted of the same layout. So instead of having multiple LED strips, we had a single strip. We had a Hall effect sensor with a magnet attached, which would refresh the LEDs as it hits that particular point. We had an Arduino running the LEDs, so it would blink at a specific point, creating the illusion of an image showing up. And we had a DC motor set up initially to act as a rotating point. For the updated version and the one that we decided to go for the project, we saw a lot of different approaches online regarding this, and we saw quite a few designs which involved a layered 3D kind of approach, and we wanted to test out how that would look in this way. So what we did different to what traditionally was done with the 3D POV that was online was we set up the strips on two different sides. Instead of having on one side, That way the illusion of the strips kind of is divided and it's easier to code for it. We set up the Hall effect sensor similar to how we did in our original workshop. And for the rotating aspect of it, we added a brushless gear motor. The brushless gear motor, it required a bit of power, so we had to get an external power supply. So the external power supply supplies enough voltage, enough current, so that the motor can move in a certain way. Also, we have a potentiometer set up so that we can adjust the speed of the POV. So we could see how different effects are formed, how these effects work, how these effects regulate. And we also coded different modes for it as well. So for now we hard coded a lot of the modes, but we are also looking into ways of making a custom software to import images onto the POV display. Also the exterior of the display is made of acrylic. We also wanted to add a suspended block so that we have a bit of height. There is a 3D printed part that holds the brushless motor, and there is a attachment on top which ensures that the 3D POV stays put, because there is a lot of friction as the motor moves. It is just to ensure that everything stays in place and there isn't a lot of noise.
Okay, when I first met people at the assembly and we had to do something for Gitex, I thought that was a good idea to make another version of my color therming, that is this device that is basically an Arduino Uno with a couple of sensors that sense how much my head is distant from the plane. And so what happens with this very simple project is that I can control the light and intensity and kind of play within a screen. So if I use both my hands, I can do some nice pattern. But the scope of this design is to show people that you can make amazing light shows with very simple technology that is basically Arduino Uno, 2 distance sensors and a bunch of LEDs. Very simple, just I would say 50 lines of code, but is again the idea behind this project that has proved to be very effective. So if you want to enjoy some nice light show, pick up an Arduino, pick up some smart LEDs and play with sensors like temperature, like distance, like sound, because it's always going to be fun. This is what I did, and I think that you can do that as well.
Hey everyone, my name is Chandni Vyas. So back in 2017, I worked with few of my colleagues to build a CNC plotter for one of the external clients of the assembly. The whole idea of the project was to bring street art and technology together. So what they wanted to do is that they wanted to build an art for which half of the art would be built by artist, but the other half would be built by a technology itself. And for this we built it using Arduino, which was powered by a software called Polargraph, and it was also powered by Twitter. So how all of this came together is that we wanted to draw the art using the Polargraph software. So that what would we do is we take a picture, we map the coordinates of the picture based on x and y axis on a canvas, and the Polargraph software will use these coordinates and send it to Arduino. And the Arduino, which will be acting as a microcontroller for the whole project, will be controlling 2 servo motors that has the pen connected to the servo motors, and will be basically moving the pen according to the coordinates that it's receiving from the Polargraph software. And as I said, all of this was powered by Twitter. So the way that the clients wanted to do it is that they had their own hashtag. So to get more people engaging or more people engaged with the whole project, the way that it worked is that the more hashtags the client received, the faster the polar graph would move the pen around. And the way that we did this was using the Twitter API, where we can actually use the REST API to count how many hashtags we are receiving in real time. So we count the hashtags and then we send that data to Arduino 2. And then the Arduino basically combines that data with the coordinates that it's receiving from polar graph to check, should I draw right now or should I just stop for a while? This was all great. It was a great combination of hardware and software. So from the hardware side, as I said, we had to take care of the servo motors as well as the servo motor that was controlling the pen. So we had to make sure that the pen wasn't always touching the canvas while it's moving from one coordinate to another coordinate. We had to make sure that the pen is lifted properly and there are no mistakes there. One of the other challenges that we faced was that so the Twitter API was all done in its own software written in Python. There was a polar graph software written in Java, and then there was Arduino. That was one of the challenges that we faced. And to resolve that issue, again, Twitter API had a lot of troubleshooting steps that we had to take to make sure nothing goes wrong from that side. For the communication between Arduino and polar graph, we basically had the polar graph machine or the polar graph software acting as a server and the Arduino acting as a client. And if something failed, the Arduino will immediately try and connect to the polar graph again, and it would just stop drawing for a while and not receive the coordinates. And on the polar graph side, we'll stop sending the coordinates. And as soon as we know that the connection is stable again, we'll start sending the coordinates. That was again from the software side. From the hardware side too, we had a lot of challenges. For example, whether we should go for 2 servos or whether we should go for 4 servo motors, because 4 servo motors will give us more accuracy while controlling the pen, but it would take more time to actually test it out. And honestly, I think the time limit was one of the biggest challenges we had. I think we had around a week to make sure that everything was working fine. So we went ahead with 2 servo motors. We took that risk, but it honestly, at the end, it all worked out pretty well. So the great thing about the whole project was that was again Arduino, because it allowed us to control each and everything about the hardware. And it doubled up the hardware processing power without any larger costs. And again, like Arduino had a lot of documentation online, so actually going into the library itself and making the changes wasn't as hard. As long as you know C++ and C, it's pretty easy to control Arduino the way it works, to go into the library and make changes. And libraries were easily accessible. It was all on GitHub with proper readme and everything, so we didn't have any issues from the Arduino side. That was pretty great.
Now we have got another very, very nice host that is part of the Arduino community here in Dubai. We are going to speak with Judy Prosetto, that is lecturer and the computer engineering and informatics of Middlesex University, and is also the manager of the robotics center. He's a very active guy. He's a very good friend of the assembly. and is a person that has done a lot for Arduino in this country. So please, Judy, tell us what's your attitude towards Arduino, and thank you
Yes.
for coming.
Thank you, Simone, for having me in this exciting moment. Arduino has been around for 15 years. At that time, it was still very expensive. I still remember that, and I'm glad now it's way, way more affordable. It becomes really an important part of our life.
Okay, so you introduced Arduino in your teaching, and how this has brought something new and fresh and affordable, and something that is understandable and useful for your students.
All right. So Arduino plays a very important role, especially in the computer engineering, because it represents the basic of a computer. The student can go down to bits and bytes of computer without hidden layer of or hidden behind the layer of operating systems, drivers, all of this. They have access directly to the hardware to make something turn on or turn off, or control things directly. And it is also exciting because Arduino is rich of resources in terms of the codes, the knowledge. The student can look for different types of codes or ideas that has been built, millions of them on the internet. They can do self-learning. For example, for some modules, we do loan the Arduino kits to the students to bring home, and they can continue experiment themselves. This really a spark of creativity and fun.
So you want the students to get this kind of attitude that it can be a hobby, can be something entertaining, but can be also their future work environment. So if they learn the Arduino way, that also has this kind of very wide sharing attitude and this very wide variety of different projects, they can find their road into their life. And by the way, you mentioned the fact that there is a lot of stuff there, but still there is space for innovation, and there is also space for instance, very quick response to very complicated situations like the one we are living now. So I have heard that you have put together for this occasion very quickly something that could be very useful for a lot of people. Please show us.
Yeah. Okay. So in this situation of coronavirus attack, I think the first symptom that we often encounter is a high body temperature, fever. So I quickly put up things on this one is the original Arduino board, and I have the I2C display over here. I built this in about 15 minutes. I copy paste from some of the codes. I modify some of them. I will send you the codes. And this is the sensor. It's a laser-based temperature sensor that can measure the temperature of a surface without have to touch it. So it's the same sensor that is used in a commercial thermometers that used by people out there. Like when you enter a shopping mall, they have these kind of sensors, right? So you can see this, that's my body temperature. And so I happen to have ice over here. Put the ice, drops down. So in the event like this, if you can't buy the no-touch thermometer, then you can build it very easily, very quickly.
Yeah, well, this is basically the difference between technology that is closed and something that is shared by the community. So someone has written probably the library that has allowed you to put this thing together in half an hour. So you didn't have to work on the sensor itself, finding out how it talks, the kind of setting the ranges, because you found the library, you put that together. You had also another nice library to drive that nice OLED screen. And so it was basically putting things together with your idea, but with parts available in the software and in the hardware domains. So this is a very interesting attitude if someone has never seen something like that, because basically it makes technology available to everyone. If you're able to read and if you're able to connect things, you are able to use the Arduino project. This is what comes out of what you've shown us.
Yes. And it is also important to draw the line here. While I'm using other people's code, pieces of code, and I put them together, I have to be willing to share these codes to the public. I will not claim this code as my own code. I come up with this myself, and or furthermore, I charge people for this. No, I shouldn't do that. Of course, if somebody asks me to build this, I could charge for the service charge, but I should not charge on the code itself, because it's community. It belongs to public. It's open source. So the same thing, we iterate this to the students, that to some extent they're allowed to take inspiration, not to copy verbatim from the codes that they find on the internet. And the most important thing is that they understand each line of the code that they are using. What does that mean? What is the effect? And of course, they have to modify to see the effect. And after that, they have to share. They have to share the code.
Okay, thank you very much for your words, and thank you very much for being part of the Dubai community. Hope you see again. We'll meet again at the assembly for the next workshop. Thank you very much. Thank you.
Thank you.
This is our next guest, is Rowan, and she's a student, is also getting to the end of her career into the American University of Sharjah. She's a brilliant coder, maker, and she discovered Arduino at a certain point of her life as a student. And let's hear from her how she discovered Arduino and what made Arduino for her a very important piece of her evolution.
The first time I dealt with the Arduino was in a lab in freshman year in college. They made us use an emulated home system in a dollhouse where the sensors would measure certain things in the house, like temperature or humidity, or turn on a fan like a servo or an actuator. And that really sparked my interest in Arduino. I didn't think that you could actually create an entire home system with just an Arduino. So that excited me more. And later on, after a while, I decided to buy my own Arduino, the Arduino Uno. And from then on, I started playing with it and following some tutorials. So that's what sparked my interest in the first place.
Okay, so your interest was starting at school, but then I think that you discovered that the whole thing is based on open source. That means sharing what you have developed, sharing your findings, sharing your project. But sharing is not just publishing the finished thing, it's giving to the others every single detail, so that everything I share is something that anyone else can take, make his, and transform into something else. So you are currently in the stage of taking these projects, but I think you might become a giver in the future. So currently explain us what you're doing now.
Yeah, that's true. I'm trying to publish and contribute to the Arduino community a bit more. I wanted to also publish about my sword game and provide all the code that's take it from GitHub and put it in the Arduino community, because I used an Arduino LilyPad for my sword game, and we used accelerometers, and we used the concept of acceleration and deceleration to detect whether the swords hit or didn't. And but before that, I would have never actually learned how to use Arduino if it wasn't for the open source community. They put a lot of tutorials there. They put all their codes, all their failures, and it's a big community. People would post comments asking for help, and the publisher would reply back, things like that. So I think
you're getting into the open source community, and you're enjoying the beauty also the internet, because we should remember that everything is possible now because there is this network that allows people to share. In the past, sharing was very difficult. There was not a place, you mentioned GitHub. GitHub is a wonder of technology. Everything is there, and you can find people that is letting you see every single bit of the piece of code, and they explain, they share, they let you modify. You can do this kind of pull requests, and you can open issues.
Exactly.
And you find that there is people there. You're never left alone, I have to say, in this community. And this is just not for Arduino, it's for the whole of the open source. But Arduino is a big part of that. We started as Arduino to push this forward, and we made especially the physical part. So I think that not just doing things behind the screen, but putting the coding and the kind of interaction into real life is another important part of the Arduino, and I think that you agree about this point.
Yeah, definitely. And the way that they actually publish, their code and provide all the failures and mistakes that they have actually is a humbling experience, because from the very beginning, as you start, um, sorry, there's a bit of noise because I'm at home. Do you
No
hear the
worry.
noise?
Yeah, this is real life. It's real life. So no problem about noises. So you are saying that you appreciate the fact that people is sharing also the failures, and
Yeah.
basically failure is a very useful experience because you learn a lot from your failures, and you learn a little bit less from your success. Success should be, I think, a process that is made of a series of failures where you
Yeah.
perfect your code, you perfect your design. So finally, when it works, there is a much more big satisfaction if it was through a painful process that made things better.
Exactly,
So
and it's so different from learning from a teacher or a professor, especially in the coding area, because once you are introduced to the computing major or things that are related to technology, it seems a bit hard, it seems a bit difficult to start and believe that you're actually creating something or that you're computing. But when you learn from a textbook or a teacher, because they have so much experience, it's hard to relate. But in the Arduino community, you can see people your age, younger, people that are hobbyists, people that are professionals, posting projects, being creative, and making all kinds of mistakes. So it encourages a person to learn and realize that it's okay to make mistakes and keep learning. It's exciting, it's supportive.
well, thank you very much for all your efforts, all your contribution to the community. And I'm very glad that you are part of this Dubai community of Arduino users. Thank you for your time, and hope to see you in other occasions. Thank you very much.
Thank you so much. Thank you.
Okay, we are moving inside this Arduino Day live stream, and we are now getting to the hands-on project. We have prepared for you a little workshop where we are going to build a talking clock. So what we are going to do is we are going to look for a talking clock on the Arduino Create website. So you can see that when you log into the Arduino main page, you find our link a little below the page, the main page, a link to the Arduino Create. You click on Create, and when you go on to Arduino Create, you have this kind of 6 tiles, and one of those tiles is the Arduino Project Hub. Arduino Project Hub is where all the projects submitted by our users are published in a curated way. So what you find here is usually a good project. So we type in talking clock, and when you type in talking clock in this kind of search bar, we look for the project, and it comes out with a number of different projects. So you see, a talking clock is quite a popular kind of project we have got on Project Hub, and we've got the Arduino talking clock that says it as it sees it. So we've got with displays, we've got with SD cards, and some kind of very sophisticated way of saying things. So let's look at this one, and this one has got, has got the display, but also has got more sophisticated way of speaking. So let's get back. This is not what we need. And okay, this is another one, and is using an SD card. So this one is using even a more sophisticated sound generation module, but we're looking for something that is more effective, that is based on the Talkie library. And here it is, simple talking clock using Arduino Uno and Talkie library. Let's click on that, and let's see what the project is all about. So we see that we've got an Arduino Uno, an RTC library, an RTC module, and a loudspeaker. And scrolling down, we see that it is very simple. So this is what we are going to use. And we are going to use the code. We are going to download all the libraries needed, and we are going to connect all the bits and pieces we've got in our setup. That is basically the loudspeaker, the amplifier, the RTC module, real-time clock module, and an Arduino Uno. Some bits and pieces will be soldered together for our
as
ease
all
of
the
use,
projects
and
that
some others
usually
will be
you
with
do,
kind of
it's important
jumpers,
to have a mat, and
so
so
that
this
we
is
can
the
recover
Arduino Uno on our green
after
mat
we
that will
finish
have
this project.
soldering things
So,
and that spanning
let's
stuff. The
get
RTC clock with already the battery.
the project.
Here is the loudspeaker, and also we do have an amplifier that will be used to get a decent volume. This is a touch, and this is the cable to connect the Arduino. Some wire is required, possibly at least 3 colors, so 2 for the power supply and 1 for the signal, and also some connection to the board. First of all, we have to solder the cables from the loudspeaker to the power amplifier. So we usually use the convention of red and black for plus and minus. It's important that you put some solder on the tip of the wires so that they will attach properly. You put some solder on the contacts, and here we solder 1 and 2 wires. Those 2 wires will go straight away to the power amplifier that has got those pins that are for left and right, but because we are using just 1 channel, we are going to solder just 1 set of wires. The little amplifier has got this left plus and minus. We are going to respect polarity, and if you don't respect polarity on the loudspeaker, you might have that the cone moves in the wrong way. So little holes, some patience, and here we solder the 2 wires of the loudspeaker. When we have done this, we have to prepare also the wires for the power supply, and the power supply will connect also to the RTC module. The RTC module has got a number of pins, and these pins are for the power supply and for the SCA and SDL. So is the interface for the SPI. We solder this little connector on the module so that we can have some sort of pass-through. So the pins you see on the right side are for the signals coming from the same pins on the left side. So soldering this little connector on the left side will allow us to use the jumpers to the Arduino board. Soldering this connector is, as usual, a procedure that takes a bit of time. Now we solder this this little PCB board where we're going to attach the other wires. We bend the pins of the connector so that we can solder our plus and minus wires that will go to the amplifier. Why are you doing this? Because we are getting the power supply from the Arduino, from the other side connector. We are getting the same plus and minus on this side of the module, and so we solder red for the plus and black for the minus, and these two wires will go in a minute to our power amplifier. Soldering, being patient to get the solder joint properly done. Sometimes you have old pieces of PCB like we have, and so it takes a little bit more time to be soldered properly, but it's done. Then the other two wires need to go into the plus and minus of the power supply. In this case, we just want to get a nice connection, so we are not going to let the wires through the holes. We are going to put some solder on the edge of the wires. We are going to put some solder on the two little holes on the PCB that are marked as power, plus and minus. As usual, black is minus and red is plus. When we have done this, we now have a power supply rail that goes from the RTC module into the power supply. Now we need the wires that are jumpers with male edges that will go into our connector on the RTC module, and then we can connect them to the Arduino. Carefully look at the pins. We have got plus, minus, and on the module is GND and VCC, and we have the SPI connections that are SDA and SCL. The Arduino has got the power, ground, and 5 volts on one side, so we're using the red and the white that are GND and VCC, that is 5 volts, and then we've got the SDL and SCA, and we are using that side of the data digital connector. We have various options to connect those pins, but basically this is the setup we need. We put some order on the wires so that we are in the right situation. Now we go back to the RPC and we have to launch the Arduino IDE. We open up our Arduino IDE and it will show up with the standard programming window. It is important that you go immediately to the menu to select the proper Arduino board, because you might have used the Arduino IDE with other boards, so we need to have Arduino Uno. We select the Arduino Uno, and now the IDE is prepared to accept the code. So this is our window. We have to switch back to the project on Project Hub. We have to copy all the code. We copy it, we paste it in the Arduino IDE. That's the whole code. Easy, just copy that. It has all the things needed to get it the time spoken. But we have got libraries. Here we've got the SPA libraries. The wire libraries are orange because already loaded. We need to find those libraries that are for the RTC clock and for the Toki. So Toki has got 2 libraries and RTC clock has got RTC lib. How we get the libraries? We go on tools and we look for the libraries, but first of all let's save our code as Toki clock. We have saved that. Now let's take care of libraries. How we find which libraries do we need? We launch a compile, and here we see that we don't have the RTC lib. So we go and open the library manager. It will show up all the libraries available. We put into the search box the RTC lib name. We find it. We click on load. We download it, we install, and then we look for the Toki library. Same choice, type Toki. We get it. We install. And at this point we should be able to compile the code without any particular problem. Let's see if it compiles. We have got that thing that is about the language. Will it part of the library? Well, it looks like it's not available as a standalone file, so most probably is part of the library of Toki itself. If the code compiles, it means that we have got everything. Let's try it. Click on compile and see if it goes. The green bar on the lower part on the right is progressing, and at the end, yes, it looks that it's compiling. So we have got everything, and the code is okay, and it's going to be uploaded. So if it compiles at the end, as it does, we can upload. And magic, when the code is uploaded, we are going to hear the time. 3, 2, 1.
The time is 12:10 p.m.
Let's see again if it says.
The time is 12:11 p.m.
Okay, every time you open the serial monitor, it will say the time again. Let's do it again once more.
The time is 12:11 p.m.
Okay, so far we have got our connection made, and what do we have now is basically the Arduino, a bunch of wires, the loudspeaker, and the real-time clock. So what happens now is that when we load for the first time the program into the Arduino will talk with the real-time clock, and the real-time clock will say, I don't know which is the right time, because I haven't been turned on since a while. So what does the software is to say, if you don't know which time is it, I'm going to give you the compilation time. And because the compiling process is quite fast, it's going to be almost on time for the real-time clock to get as a timestamp. Then what we have done some testing, and we have found out that we need a capacitor to be connected at the input of the amplifier, so that we get rid a little bit of some DC component that is basically the thing that is making the loudspeaker to do the kind of bump when you switch it on, and also it gives us some better frequency response. So we have got all the wires connected, and what happens, we didn't use the push button that we provided at the beginning, just because we found out that this clock is telling the time every minute. So for our demonstration purposes, we made this little clock that it tells the time every minute. You can alter the code so that it doesn't tell it every minute. You can add a push button so that you press it and you get the time. But for our purposes, we think that is a good demo, and the Arduino speaking is quite a funny thing. It speaks with a very robotic voice. It's a kind of 80s way of speaking, but that's a nice thing of having an 8-bit old style thing that is on our desk. So this is basically the whole project, and as you see from the various zooms on the components, you can arrange the thing with some long wires as we did, or you can make a more ordered layout with shorter wires. We kept the Arduino with some kind of male jumpers so that we can still unplug everything and keep the Arduino for other projects. If you want to make something more stable, you can connect in a more stable way. Okay, so this was our workshop. I hope that you'll have enjoyed that. I think that you can replicate that. You can go online and get the code from the same Project Hub page we used. Just for your memory, it's the project that is called Simple Talking Clock. So if you're looking for a simple talking clock on our Project Hub, you'll find out the whole project. It's using directly the loudspeaker connected to the Arduino on the pins, and as you should have seen from the video, we have connected the loudspeaker to the pin digital number 3. You find all this information also on the Talkie libraries, and so if you connect to GitHub and search for Talkie, or you just click on more information when you download the Talkie thing from the library manager, you find out that the pin are 11 and 3. You can use both if you are just using one loudspeaker, or as we did, we use an amplifier and we just use pin 3. Thank you for your time, and let's move ahead with our Arduino Day. Okay, I think that we have also to remind you something. Remember that at the end of this event, we'll have around about 20 minutes of Q&A, so please send in your questions, and you have various means to send them in. Send email, or you can make a tweet, or you can send them on Facebook. But please send your questions. I'll be.
Send them on the live chat.
and they can also send. You can also use the live chat. But please send in your questions, because at the end of this live session, we'll reply to your questions. Thank you.
Okay, I'm just going to leave that on for 1 second so that you can get all the details for a few more minutes, for a few more seconds.
Okay.
You're still on there. Okay, now I'm going to go over to the quiz slides. The next question.
Hello, I'm Mark, and I've worked with assembly in 2018 and 19. My main project was the 3D printed humanoid arm, and we used a lot of open source and widely available information and code and material. Our main goal was to help people understand that finding technology and integrating it with real life and basically making cool projects is not that hard of a task. All you need is a little bit of dedication, and you should be on your way. So the overview of the project was there was a leap motion sensor that captured the motion of the user's arm, and it sent it back to code that was written in processing, and that code basically translates the coordinates of the fingers and the wrist and the elbow and sends it back to the Arduino that can drive the motors. So to give you like more details about the project, this project was fully 3D printed. We took almost about 2 weeks to print all the parts, and we ran into some trouble because not all of them were fitting the standard local servos here. So we have to also tweak that a little. After that, we tried to like put it all together. With the servos, we used approximately 6 to 7 servos, because each finger had a servo like allocated to it, and there was one servo for the wrist, so it does the wrist rotation, and another servo that was integrated later, and that was for the elbow motion. Of course, for that servo, we needed a bigger one because it would be driving a lot of weight. And for the muscle movement or the contraction of the fingers, we used fishing cords, which are basically very strong, very tensile fishing string, and they connect to the tip of the finger and go through a tunnel back to the servo. So when the servo rotates, it pulls the plug, it pulls the string, and the finger contracts. And to bring the finger back to its initial place, we had it fitted with parachute cords, which are very elastic, and they usually stay in form. So when the motor relaxes, the tension on the string itself, the tension on the parachute cords, pulls the finger back to its place. On the software side of the whole project, there was a processing code that basically took the data from the leap motion, and we coded the Arduino through processing by using the Fermata protocol, which basically gives you the ability to surrender your hardware of the Arduino to another platform like Unity, or you can put it on processing, or whichever platform you want to use or comfortable with using. And you can code the hardware with your within the same code that you coded the other aspects of your project in. All of the Arduino ports were giving out, of course, PWM because we were driving servo motors. And we ran a little bit into a power issue because these were a lot of servos. And yeah, not one Arduino can have that. So we hooked up the whole thing to a pretty big power bank that's giving 2100 milliamps. But it ran smoothly after that. Yeah, and that's pretty much it.
Hi, my name is Zinity, and I worked on the revamped humanoid. In the first version of the arm, the user inputs were taken in through a leap motion sensor and were replicated on the arm. In the new version, we added a game mode for rock, paper, scissors, which took the user inputs again from the leap motion and played against the user. The way this was done was the inputs coming into the leap motion were run through a neural network to process whether the user has put a paper, rock, or scissors, and that allowed the neural network to identify and play against. The way this was done was by having the neural network send signals on the serial monitor to the Arduino based on whatever the user has selected. So say if it was a paper, it would send a value like A. If it was a rock, it would send B, and etc. And based on that, the Arduino would process it and try to play fairly against the user.
Okay, so before we go on, we are of course showing you all the Arduino projects, but these are the bigger projects that we worked on over months and done them for major events and all that. However, the assembly is also a community that meets every week for workshops. So every week we are building mini projects and we're doing lots of different things, not just with Arduino, but with all sorts of skills. And we believe in building something at the end of every session. And so Arduino, of course, is one of the main technologies that we use just specifically for that. In fact, we've done probably more Arduino projects than any other platform on there, but we'll give you a small preview about what we do, and I will actually just walk you over the different projects right now that we have done, the different workshops. Okay, can we start the video? Yeah. Okay. Okay, so this was an interesting one we did, which was half science experiment, half technical workshop. Now, magnetic levitation, of course, is the underlying part of what you use even in when you get your hyperloops and all that. But we wanted to build a very simple proof of concept, and we just wanted to show how you can levitate. So the Arduino was switching on and off the electromagnet, hundreds of thousands of times a second, and it was just maintaining exactly the right balance. So it was very key to actually just coordinate that, and you can see how we got that. The other workshop that we did that was very popular was gesture control robotics. You saw how the arm was working as well. So we riffed off on that. We showed people how they can use the leap motion and translate. You can see the arm there. The arm was just for demonstration, but to give them an idea of how the arm works, we made small cardboard cutouts which we just had servo motors pulling on the fingers with that, and that the motion was synced up with leap motion and processing. So once they got the hang of leap motion, they could actually connect them to the servos and just see how the Arduino could drive it so that it would mimic the hand gestures. So very simple robotics lesson, but a very effective one, and people were very interested with that. You can see our arm is very makeshift. We just use little pipes and all that. Of course, we went with a full robot as well. You've obviously seen this design before, so we built a walking and dancing robot. It's just a 3D printed box with a few servos at different articulation points and driven by an Arduino, but with the shield also applied there. So everything was self-contained, and the robot could be programmed according to different motions and different, you could even time it according to a song. So when we do these assembly workshops, we make sure that every, say, people form into teams, and they're, say 5 people at a time would have access to a kit. So people collaborated and worked there. You can see ultrasonics. We didn't use that there, but we could probably actually do that. Another workshop that we did that was a lot of fun was the laser piano. I mean, laser pianos and laser harps and these are usually done for big installations, but the concepts are very simple. And we just, of course, we didn't bother with the 3D printed case here, but we just used a little bit of a rudimentary setup with lasers there. And okay, you can't hear the sound right now, but you could play different tones that were generated by the piezo buzzer whenever the thing was. Now, you recognize Judy from earlier on. Judy has also done quite a few assembly workshops. Like I said, he's an old friend of the assembly. Now, this was something Judy had devised where he wanted to see how you could trigger a camera shutter on your mobile phone through your audio jack. And, he did a lot of research, so you can see we got a very detailed explanation there. And every time that it ran, you got that. This was another recent workshop we did where we showed people how they can use capacitive touch for fun objects. So you can see, like, you can press every time you press the coin, the LED went on and off. Then we showed them how you can make a flower petal piano. We showed them how you can write text on paper, and then that actually suits them. So they were able to use it as a keyboard just by pressing down on text that's over there. And then finally, this was our rose petal. We picked flower petals and we actually got them connected up so that we could actually play the piano with them. This was another simple fun workshop we did where we wanted to show people how they can build a simple LCD game using an Arduino and an LCD screen. We did take it up a bit a notch because we also showed them how they can convert it for the OLED. So there were a few different aspects of that. And people are, one of the things people don't realize is our crowd is very eclectic, and we have a lot of people who are interested in building things. They're not just software people. Even if they are software people, they're interested in working with hardware. So we have a very different crowd, and so this was some of the simple games. Obviously the OLED, you can see, is a little more complex, but we showed them how to build that. So there was plenty that we could do with that. Now, this is something we did purchase new equipment. We used the Arduino IoT Cloud. Again, Arduino very graciously provided us with a professional account for that. The Arduino IoT Cloud makes life a lot easier, and we also synced it up with Telegram, so that we built a Telegram bot that could communicate with the Arduino IoT Cloud for home automation. So you could switch on your lights and switch off your lights remotely. So as you can see in that demo. Right, so that's it. I just wanted to show you a little bit about that. We will then now take you back to the quiz slides. Next one coming up now.
Okay, our next guest is Anudip, that is he graduated at the BITS Balani University and currently is even.
Hey everyone, my name is Chandni Vyas.
Okay, our next guest is Anudip, that is he graduated at the BITS Balani University and currently is even research advisor for robotics in this university. So this is a very good example on how you start with an Arduino and your profession turns into something that is very much Arduino related. So please, Anudip, tell us when you first discovered Arduino.
Oh, so I first discovered Arduino during a workshop with the assembly here in Dubai. Back in the time, I was studying my first year as an electronics engineer. Uh, so I got started with microcontrollers, but I never knew how to start using or start building projects with using an actual microcontroller. So that's when Arduino came in, and the simplicity of Arduino actually helped kick things off for me, and that's how things started with Arduino. During the workshop, I learned how to tinker with it, and then I continued tinkering and learning more and more about the Arduino. And by 2 years from then, I started building serious stuff with it. And yeah, most of my robotic projects were based on Arduino. And from there, we continued with the Arduino. Yeah.
Okay, so what you found interesting was the simplicity and how it demystified the fact that microcontrollers are something that engineers can use. So you were
Exactly.
one by the simplicity. And also I've been told that you are making amazing stuff currently. So please show us some of your creation that are born as Arduino stuff and then became some even more sophisticated product. Please show us.
Sure, sure. So this is a rover we use at the lab. Its controller is mainly based on an Arduino controller, where we designed the circuit around the Arduino chip as an Arduino and a bunch of wires. And once we were happy with it, it turned into a proper board which is controlling this robot. Yeah.
Wow, so this robot is quite sophisticated. I see you are using specific kind of wheels that allow you to have the machine to move in different directions. So also the software that controls that robot has to be something that is quite sophisticated. Have you got any particular thing inside like AI or some kind of remote control thing into this robot?
Yeah, so this robot is actually being built to be fully autonomous. It's one of our core robots for autonomous navigation research in indoor environments. So yeah, there is a secondary brain which we attach, which does most of the AI-based work and feeds the data to the Arduino so that the Arduino is able to control the wheels and make the robot move in different directions or how we want to move the robot. Yeah.
Okay, so what happens here is that you found in Arduino the solution that allowed you with its environment, with the software, with the libraries, with the open source thing you were able to find around. It was the first bit of a puzzle that is much more complicated, that is your design for these autonomous robots, that to me look quite a sophisticated application. But I think that what you found is that the time to market or the time to a prototype was much shorter thanks to Arduino. And
exactly.
Before you got to those robots, was there any kind of project is worth sharing with us?
Before we got to this robot, I always like to build rovers. So the first robot I built was, I used an Arduino with a BLE, a Bluetooth low energy module, and we integrated it so that we could make a remote control robot, right? Remote control RC car using a Bluetooth this thing. I also used Arduino for a very interesting project I would like to tell you. This was actually done for Philips, where we were trying to prototype of an IoT coffee machine, a coffee machine which we could control with our apps, with a mobile app. So the way we did that was we actually remote everything inside the coffee machine, the main control circuit, and replaced it with an Arduino-based Arduino YUN, actually Arduino YUN. We replaced that, and through that we were able to build this prototype IoT coffee machine back in 2015, I think. Yeah.
Wow. That was quite an achievement. Okay, so it looks like you are a very good example on how you can benefit from the open source, from the sharing attitude, and I think they are very, very good example of on how the Dubai community of Arduino makers and lovers is really getting somewhere. So it's not just hobby, it's real work. you're in a position that
Yes.
you will leave some signs, some footprints into the history of technology, because you're working in a very interesting way on interesting stuff and innovative projects. So thank you very much for using Arduino. Thank you very much for being part of this community, and I hope you will hear again about you in the close future. Thank you very much for your
It's a
time.
pleasure. It's a pleasure. Thank you. Thank you very much.
Okay, and here we start with our interviews with the users of the Arduino and the community that we've got here in Dubai. And we are going to speak with Vishweshwar of GEMS Modern Academy. And this is a student that has already made very interesting designs with Arduino. But let's hear from him how he started with Arduino.
Hi, I initially started with Arduino for a very personal cause. My grandfather's friend, who was a visually impaired person, found it difficult to navigate through obstacles. So I wanted to create a wearable gadget that would detect obstacles and alert her. So that's when I came across an Arduino board, which served the very purpose of being small, satisfying the purpose of detecting obstacles and alerting the user. And it mainly made the gadget wearable. So here I have got the gadget. This is an Arduino Nano board connected to an ultrasonic sensor, and along with the buzzer that is being packed in an acrylic case. It's wearable. This is what I started with. Now, after finding through users that buzzer was really uncomfortable for them because it helped. It made other people, their surroundings, also know that they were using such a gadget. I shifted to a pager motor, vibration-based alerting systems. So that's how I discovered Arduino and got to use that in my project.
Okay, so basically what you did is you also were looking onto the internet to find out the inspiration, and you probably found out that this issue your grandfather friend had is quite a common issue. But I see that what you did is you took the basic design and you did some kind of co-design with the final user, asking, would you like a beeper or would you like something more discreet? And the outcome was changing the design into something that was more discreet. So I think that you also have that board with the vibration stuff to show us. Can you show it to us?
Yeah, so next project that I did was for arthritis.
No, well, sorry, I'm saying you have also the version with the vibrator of the.
Yeah, so you can see that this is
exactly
the one with the pager motor.
Yes.
So we have the nano board over here, and that's the ultrasonic sensor, and here's the pager motor. This is the modification that I made. I'm planning to pack the same circuit in a similar acrylic case, with a bit more style and stuff to it, and distribute it to actual persons.
Okay, so that was the start, but you have also something much more sophisticated to show us as a design. Please.
Yeah, so I was very excited to show that initially, and that's when this popped out. That this is OMM, oscillation motivated movement. Again, a wearable gadget for arthritis affected patient. I used the concept of pain easing with the help of vibrations. So this gadget is nothing more than a massager essentially that uses Arduino and HC06 Bluetooth chip, and it's wearable. But the main twist, or the
difference,
selling point.
The value added feature.
Yeah, so selling point of this gadget lies in the application that I use. It connects to the user's gadget and tracks the usage history, and also connects the user to doctors who can help them progress medically in a scientific manner.
Well, so basically, because you're tracking the usage of the device, and also you are tracking the benefit on the patient, a doctor is capable of understanding if a particular way of vibrating the device, the frequency, the time in between every treatment can make a difference. So what you're doing is you're basically supplying doctors the outcome of more or less a research, because you are letting the device become a research tool. So you're not just helping your final user with that massage machine, but you're also providing to the doctors information that will help them to say, well, this is not just a device for this case, but we have found out of many users that the effects are those ones. So basically what you've done to me is a very mind-opening approach to the problem, because you were not just trying to solve one issue, you were trying to create a device that has a purpose in general terms. So this to me is very much the spirit of making and doing open source stuff. You benefited from other from other people's work with the ultrasound thing, but I think that if you share that project with the community will be very happy to be part of this project, supplying to doctors also what they found with their patients. And so to me, this is very nice. Thank you very much. I think that GEM Modern Academy has a very talented student, and I thank you and your teachers for the time you gave us. Thank you very much.
Thank you so much.
Please send in your questions via email, on Twitter, on the live chat, and on Facebook. But I also have some interesting news for you. For the people that didn't tune in since the beginning, well, first of all, remember that anytime you see those questions, you have an option to get some Arduino swag. But we just have got information for our friends in Italy that the activity is starting there as well, and the nice news is that we can select a couple of questions from yours and put those questions to the big guys at Arduino in Italy, and this will go online around about 6 o'clock Dubai time. So if you have particular questions that you would like us to put to the team in Turin and in the other countries scattered around the world, but the real Arduino guys, please send us those questions, because we are going to be able to put a couple of them to our people in Turin. Send your questions. For the questions that are going to be answered by me, this will happen at the end of this session. So we'll have some kind of unboxing in a few minutes, and then we'll go with the Q&A. And also we are going to tell you who's going to be the people that will have some interesting swag from us.
Okay, we're going to take the
We have some little change in our agenda to accomplish some kind of things with technicalities we have, and what I would like to show you is the latest achievements that Arduino made, and is the birth of the new family of products. So during the unboxing you'll see the normal products, but there is something that has been really launched in an event before the coronavirus just stopped everything from happening, and it's called the Arduino Pro family. And the Arduino Pro family is a new type of boards that have been designed for professional application. It's something that has as a peculiarity specification like double processor. Is going to be a family of products that run different languages. So we are moving from the Arduino C language type to something like MicroPython and other languages. So you will have a choice of programming this new Pro board in many different ways. So let's see with the video what it's all about. Right, we have got your questions coming in and we are working on that, so this is why we had to interrupt for a few minutes. I would like, before we go on to the last bits of our long session that will be the unboxing of the products, I would like to explain you a couple of things about a topic that sometimes comes out in forums, in discussions, the difference between the original Arduino boards and the compatible Arduino boards, the clones and the counterfeits. Basically, it's not just a word made of Arduino boards like, you know, this one. This is an original Arduino board. This one as well is an original Arduino board. You see there's a difference in color, but you know, this is an old one and this is a new one. And by the way, this one behind, you can't see that, but there is a signature of Massimo that says "To Simone" by Massimo Banzi. I'm very proud of that board. And let's go back to the issue about why buying compatible boards is okay and buying the counterfeit and the clones boards is not that much okay. First of all, when a board, well, as we said some time ago at the beginning of this thing, Arduino is an open hardware platform. So being an open hardware platform means that there is no limitation for anyone to pick up the design and make their own board. There is a limit about the name. So Arduino is a trademark, and so it shouldn't be used to qualify a board that has been made with the Arduino design. So an Arduino compatible board, so you can build, and you see on the market the Funduinos, the Roboduinos, the whatever Duinos, and that's okay. What is a problem is when you get a board that really looks like an original one, but is not an original one. And by the way, it costs a lot less. You know, components do have a price, and when you are using components, you can choose from first quality, second quality. You have different qualities for the same component in one case, or worse, you might have components that are labeled as particular ones, but are not exactly those. There are components that are of lesser quality with the specification that are just fake in terms of what is written on the component themselves, and these are the most dangerous products because those look like the original but are not performing like the original. You see, I showed you this one. This is a board that has got something like, I think, 4 or 5 years. I've been doing many projects with this board and it's still alive and kicking. I can tell you that I stumbled into a number of boards that were looking like the original ones but were made with lesser reliable components, and they just broke. The regulator for the voltage just blew up and the components were damaged easily. So the point is that if you want to buy a board, either you go for the original one or you go for a compatible one. But please don't get those boards that are made as lookalikes. There is no reason why they can't produce their own branded boards. If they're using the Arduino brand, they are doing something that is not good for them, for you, and for us. So please be careful when you're buying Arduino boards. No question?
No, you can carry on with those questions.
Okay, so it looks like we can start to answer some questions to send.
You have to read it out also.
Okay, let me just switch to the document. We've got, and pardon me if I don't going to pronounce your name, we've got Takir that says, I would like to turn on and off lights remotely or using a mobile phone. Which board and equipment is required for this? Well, you're typically doing something that is an Internet of Things application. And let me check in our assortment here. We have got the Arduino Nano 33 IoT. That could be the right board for you. It's somewhere in this mess. Okay. Basically, what you need is an IoT enabled board that can work with Wi-Fi. And the thing that you have to be very careful about is the fact that when you want to switch on and off a light, there has to be a relay that does the hard job of switching on and off stuff, but that relay will have
high voltage going through that. So the Arduino Nano 33 IoT is a board that contains on it an ESP chip for the communication with the Wi-Fi. But the point is that you'll have to connect some of the pins to the relay, and the relay will switch on and off. Then I would suggest you to go with things like Tasmota, that is an open source package. We ran here at the assembly a workshop that was exactly about that. I think 3 weeks ago, 4 weeks ago, roughly, probably 1 month ago. But basically, if you look for Tasmota on the web, you find a very, very good open source solution that manages all this kind of Wi-Fi communication. And this is for Takir question. Miali asks, what Arduino board is best to start with? Which one can go for its versatile nature so that I can use that for several projects? Well, if you are not an expert, you are starting with Arduino, I know that the smaller boards are sexier, and I know that you might like to build something like this very compact and nice. This is a LCD watch with big numbers. Maybe I can manage to connect it to some power supply so that I can show you that it switches on. 1 sec, I take one cable, one micro USB cable, please, and so I can show you. But this is the Arduino board with those connectors. Those connectors are very useful because you can use the plug-in wires. So you can just connect these jumpers. You don't have to make any soldering, and these jumpers can allow you to connect anything. Thank you for the cable. So let me show you what happens when I power up my watch. And this is a very simple project, and it just shows you when it starts up some time. Okay, resetting, and it says that is the 21st. It keeps the time and is 13:26. So maybe you can see the image on the LCD, but this is some sort of more expert kind of design because I'm using a small board, a small Arduino, real-time clock, and LCD, all soldered. The same stuff can be done exactly the same on this one, but using those kind of jumpers, you don't have to solder, and so this is the best solution. Start with an Arduino Uno. It's bigger, but is compatible. And the nice thing about the Arduino is that whenever you develop some code, some sketches, those sketches can run across the different boards with minimal adjustments. So we do have what we call the libraries, and those libraries make the connection of the real-time clock, the LCD board, and by the way, there was a question about LCD, and it looks like not a single one of you got it right. That's a pity, but that's not the point. Anyway, as I was saying, so with the Arduino Uno, you can connect things easy, but you can then evolve because the code will be the same. If you want to do something with the Internet of Things, we do have an Arduino Uno Wi-Fi that is the same size of this one, but with the Wi-Fi module that is available. And then you can go forward. What happens is that when you have these boards that do have these pinouts, so let's do some unboxing here. And when you get this board that do have the connectors, these connectors can go onto, see those pins, can go into what is called a breadboard, and from the breadboard you do the kind of connection. You still have those connectors, but this is a board that is a little bit less friendly for the basic users.
We've got the last question. The last swag question.
Oh, yeah.
So it's the last chance for people to get it. So I'm just, shall we queue it up?
Okay, they're telling me that we've got one last swag to go, so let's
then you do the unboxing.
Yeah, let's stop with the questions for a while. We do the unboxing, but before we show you the last question, prepare your email client to send out the answer.
We've got already like 8 winners, so
okay.
We've got 8 people.
Let's go with the question. 3, 2, 1. Question coming up.
Okay, we are now at the point where some of your questions will get an answer showing you the assortment of the Arduino boards. So what we are going to do, you see here I've got lots of boxes, and I'm going to switch to a more and more detailed view with my hands, and you'll see the boards in true detail. So let's switch to the hands-on part. Okay, hi everybody. We are now looking into the Arduino products because since the beginning a lot of things have happened, and from 2005 where we had the very first Arduino board, a lot of things have happened and a lot of new designs have been implemented and brought into the family. So what we're going to do in the next minutes, in the next quarter of hour, I'm going to show you from where we started to where we are going now. That is probably something that is very interesting for any Arduino fan and any Arduino member of the community. So basically what we have here is the good old Arduino Uno board. As you can see, is the standard initial format, and on this format Arduino has made more or less a standard, and a lot of shields have been designed so that they were fitting into this kind of connection style. On the same standard we've got, you know, other boards like the Arduino Uno Wi-Fi. This is the Arduino Uno Wi-Fi, the new revision, and basically it really looks like the other Arduino. Let's see them side by side, and from what you can notice, the main microcontroller is a different one, and we also have got this tiny little module that is the Wi-Fi module. So this is basically like the Arduino Uno but with a Wi-Fi module on that. So this was the beginning. Then we got other boards, and this is another very, very nice board that was used in a number of projects. So if we just unbox this, we can appreciate the beauty of the Arduino Mega. So the Arduino Mega is this board that has got a more powerful microcontroller, still the same family, but the thing is that this bigger microcontroller has got more memory and has got a lot more of connection. So this was the board that was used for making all the initial 3D printers, because all these connectors were the right thing to connect all the end stops, the start and stop micro switches, the motors that needed more than one single connection to be used. And so this was the board that made the 3D printing possible. So what happened? Because this format was very successful, when Arduino designed the new boards, they took time to think on how to make, for instance, the new Maker boards the same format as the Uno. So when we are looking at this tiny little board, this is something that probably not many of you have seen so far, but this is called the Maker, you can read that, is the Maker to Uno adapter. So what it does, it brings back the Arduino kind of connector thing into the Maker board environment. So you can use a Maker board, and basically this is the new Maker, Arduino Maker. Basically this is the Maker Wi-Fi 1010, and so the Maker Wi-Fi 1010 on this board basically becomes very much like this board, because we've got the same kind of connector, the same module, and it's a good way to have
the Maker format into the Arduino format for some sort of project. But still, the Maker format was the big change that was made some time ago, a couple of years ago, and it brought the Arduino into a new dimension. You know, with the basic and standard boards, we had the Yun, that was a very interesting board that had some kind of Wi-Fi connectivity and was managing the internet stack protocols and these kind of things, but it was with this standard Uno format. The Maker boards were the big innovation, and it all started with the Maker 1000, that is this board. And as you see, there was a module here that is the Wi-Fi module, and the Wi-Fi module was driven by a SAMD chip that was hosted into this block, and there was the Wi-Fi antenna. So this was the first step towards a new kind of board. You see that we've got the USB connector, but also we've got this connector that is good for having an external lithium polymer battery. Things changed, but basically what happened is that the connectors were very much like the Uno original kind of thing. So you were able to run most of the software on these boards as well. And the basic idea of having a board that is capable of hosting shields was kept. But the shields were going from the standard shields for the Arduino Uno format into this new kind of shape that allows us to have still a shield that goes on top of our Maker boards, but it's smaller. So what happens is that we have smaller circuits, smaller application, smaller footprint devices, and this stuff also is not just smaller, it eats less energy, and so it's the right solution to get into this wonderful world of the Internet of Things. And so when the first Maker board came out, there was an improvement in the whole line of products. We thought deeply about the Internet of Things, and because Arduino is basically a neutral company, there wasn't a precise choice of a particular technology for the Internet of Things. And if you have followed the Internet of Things phenomenon, you know that there is a variety of different communication solutions. So we have got the Wi-Fi, there is the Bluetooth, and also this is the new 1010 that has got a smaller module, and this smaller module basically has still the Wi-Fi and Bluetooth connectivity. So let's get them straight. Then what we did is we came with the Sigfox solution. Sigfox is a network that is based on a number of gateways around the country, around a number of nations, and you can have this board that talks with the Sigfox gateway and relays the information to your application on the web, and it does that very efficiently, and it can run on very little power. But Sigfox is just one, so we also produce this board that is with LoRaWAN, and LoRa is another low power and low speed kind of wide area network technology. You can use these boards as standalone boards. You can connect two of those LoRa boards together, and these two boards will communicate, or you can set up a LoRa gateway, and this LoRa gateway will bring the data into the internet, and then it will just get into, for instance, our Arduino cloud or stuff like that. Then, because we didn't think of stopping there, we added this board that is the GSM one. So this module is a GSM module and allows you to use a standard SIM card that goes in here, and the SIM card that goes in here is a data-enabled SIM card. So basically what we are seeing here is a variety of things, and also we thought about the narrowband, and this is not GSM, is narrowband. That is the next technology in terms of communication over cellular networks, and this GSM and narrowband thing allow you to have completely different approaches. GSM allows you to have a lot of data, or you can have SMSs, but you can have the real internet connected through mobile network. This one instead thinks about the necessity of having a lot less data to be transferred, but it can rely on the openness and on the coverage of the cellular network. So basically, just to recap, we've got Wi-Fi, we've got Sigfox, and we've got LoRa. We also got GSM, and we've got the narrowband thing. And these are the new maker boards. And as you see, there are solutions for every single need. You can go from standard local kind of communication, even on Bluetooth. So you go from the 2 meters of the Bluetooth to the 100 meters of the Wi-Fi, and then you can switch to the something like 10 kilometers, and you can go even further, or you can rely on the worldwide coverage of the GSM network, or you can rely on the narrowband. That is the next technology that is coming out with the new 5G networks and evolved 4Gs. So this is the setup. And as I said earlier, what we did as well is we did create a number of shields, and those shields allow you to have interesting applications. The attitude for the maker boards is to get more professional. So for instance, this is an interesting board, is an interesting shield that allows you to connect with a CAN bus. CAN bus is something you have in cars, and probably a lot of you have the problem of your engine light turning on and having this kind of problem. What is going wrong with my car? Well, with a shield like this, you can connect to your car and interrogate your CAN bus and get to know what's going on. But we don't stop there. There is a very interesting application that is a 485 serial interface. This is an industry standard interface, so if you want to do some kind of industrial applications, PLCs, or these kind of things, the 485 serial connection allows you much longer and much more reliable connection than the plain serial port. And this allows you to have, for instance, some sort of PLC approach or industrial close to a PLC solution. And this is an industry standard that is driven by standard libraries, and we have provided also our libraries. But you can configure this little shield for your needs. Maybe you need to do something more serious about the temperature, and this is our thermocouple shield. You connect your thermocouple here, a K-type. You can also have a digital thermometer here. And the thing is that this module allows you to measure temperatures in a much wider range. So what happens with a thermocouple is that you can go from below 0 to almost, I think, around about 700 degrees Celsius. So it's again a solution that can be used for the industry. So we kept developing this kind of shields and solutions, but we also thought about something that was more entertaining. And apart from having the environment shield, that this is this one that allows you to have a lot of sensors, so you can measure the humidity, the light, the UV, the pressure. We made also this one. Let me unpack this nice little box. We went back to something that is always nice. So we prepared this little shield here. That is the RGB shield. This is fully compatible with our maker boards. And what's nice of this is that this is an array, is a matrix of LEDs that can display the RGB colors individually. So you have every one of these LEDs that are the smart pixels. So each of these pixels can be turned on and off, just talking to all these through the usual data pin. Actually, this is using the APA 102. So if you are aware about smart pixels, this is a very good quality board that is capable of showing very fast images and animations. So it's something that is with, it has been designed with the perspective of offering the best-in-class display for those smart pixels. So we are going into some depth about these products, but basically the message that is coming out is that there is a lot that has been developed. So what about the origins of the Arduino? Well, at a certain point there was some sort of comeback, and the comeback means that the Arduino went back to its basic stuff, that is the Nano. The Nano board of Arduino was a very big success. Basically, it's funny to say, but the Nano has been the most cloned and counterfeited board all around the world because it was very cost effective, had a small footprint, and it was an Arduino with a small footprint, but with all the compatibility of the standard Arduino Uno board. So let's unpack this one and just let's enjoy the beauty of this very tiny little board. And here we go. So this is the new Arduino Nano board, and is currently available in this configuration with or without the headers soldered. Basically, it's the Arduino Atmega 4809, and this chip is compatible with the other Forma 382 Atmega processor, and we have got some components here that allow the board to be fully compatible with 5-volt power supply. So this board is basically pin-to-pin compatible, and also a direct replacement for the Arduino Nano standard good old board that is basically now quite difficult to find with a good quality. You can have this one, is newer and is a little bit more powerful because we've got a little bit more of memory, and is running at 20 megahertz, 48 kilobyte of flash, 6 kilobyte of static RAM, and it has got all the user interfaces, so USB, SPI, I2C, and UART. So being a new microcontroller is a good opportunity to have something more interesting. But we didn't stop there. So the Nano family was brought back to life with other boards that are basically this other one that is very interesting, that is the Nano non è finito, finisce. Okay. Right. So you saw that we have got a lot of boards, but it doesn't end here. We keep developing new boards, we keep developing new solutions, and we are also trying to put some kind of new strategies, especially for the cloud part. So some of you has probably heard about the Arduino Sim. That is a solution to use our SIM-enabled boards across the whole of the world, so that you can bring your projects around the country and have it working anywhere. We are also getting to the end of this long day. For us has been a very big pleasure to be able to show you what we have done as a community, as the assembly, and I hope that you were able to enjoy together with us the power, the fact that the Arduino is good for everybody. You saw a lot of projects, you saw a lot of workshops. So we are going towards the last segment, that is the last Q question answers, and also we are going to tell you who are going to be the lucky guys that have the swag that will be available for them to be taken. That's showing me something, so let me get what the
You're showing both? Okay, I'm back. I'm
Yes,
keeping some social
keep the
distance here.
social distance.
Social distance, we're being very careful. I just wanted to come back here. I know Simone's been stellar in doing all the content, and we're very lucky to have him. So very grateful. Thank you, Simone. I mean, we do a lot of collaboration together, but this was something special. So thank you for that. I think before we get into the swag giveaway, we just had some more questions coming in. So maybe you want to just field those, and then we'll get over to the swag giveaway.
Yes, I see that there are some questions. You know, the topic, the most important topic I've been seeing coming through the questions is about the new Internet of Things. And as you saw into the boards unboxing, we do have a number of different boards, from the very small ones, the new Nano with IoT, to the Sense BLE. We cover from Bluetooth low energy up to wide area networks with the LoRa and the Sigfox stuff, also with the GSM. So basically, still we do have a microcontroller and the communication means. So it's not a system on chip, as someone of you is asking. System on chip means that there is an operating system, and the operating system, like a Raspberry Pi or a BeagleBone or other boards, do eat up resources and are very good for applications where you need to have some sort of web interface. The Internet of Things is usually a much less intense communication, and this is why, for instance, there are technologies like Sigfox and LoRa that do allow you to send 100 bytes per message and maybe something like 50 messages per day. So what is that for? Imagine you have to send out the temperature and the humidity of a field that is where a culture of corn is done. You place those sensors scattered into the ground, and you want those sensors that probably you forgot where you placed to live for maybe 2-3 years with a single battery. So you need very low power, and also you need very little data, because to send out voltage of temperature, humidity is basically 4 digits, so it could be something like 20 bytes. And so the messaging you have in Internet of Things shouldn't be an internet connection with web pages. It has to be a much simpler transmission of the relevant data. So a lot of our boards are made in that perspective. So when you're thinking about Internet of Things, even switching off the light at your place, switch on 1 byte, switch off another byte. You want to get back temperature, humidity, and pressure information. Let's have a couple of bytes each. So it's still 6 bytes you get back. And this is what is all about Internet of Things. It's not the Wi-Fi, wide broadband, these kind of things. It's very little data sent at intervals that might be every hour, every 2 hours. So it's very little communication, and mainly you might go for a board that just goes to sleep a lot of time and then wakes up, sends the data, goes back to sleep. And this is how you get this kind of 3-4 years
So
of
it's not
life.
keeping a constant connection. It's
No, that's not the Internet of Things. Last question.
So BLE would also be, even your what's it called, low band, it's you could use it for IoT that is not very intensive also, right? Like a NB IoT.
Okay, the narrowband IoT is the other technology, and when we are thinking about the IoT, you have to think about the radius in which the communication has to happen. So when you're speaking about very low power and very close thing, let's make Bluetooth connection. Everyone has got this kind of sports Fitbit stuff. Okay, they speak with low power Bluetooth to your smartphone, and the smartphone is the bridge to get to the server, or it may stay local. Very narrow. Then you go to actually Wi-Fi, but then you go to LoRa, Sigfox, GSM, narrowband, that are growing in terms of the radius and the coverage. For LoRa and Sigfox, you can make your own kind of areas of coverage, and you can think about a farm that has got his LoRa gateway and is communicating with all the LoRa devices scattered around the fields. This is a typical application. So power, amount of data, and the kind of coverage is something that usually you have to consider when you want to build some sort of thing. As Arduino, we cover all the various technology. This is what we choose. We are neutral, and we are supporting them all.
So do we have any time for any more questions?
I think that we might have just the last one.
Okay, well, quick answer there.
There is this question that might need some kind of understanding, because Amal is asking which is the best Arduino in terms of environment.
So I think maybe if I could just reword it, Amal Nazir, right? Like, I mean, we could just say maybe, what about environmental considerations? I guess one of the things you said is like narrowband IoT is there, and low power, maybe that is. It's a very broad question, but we could frame it in a few different ways, I guess.
Yeah, of course, we do care, and this is something that Arduino has always been proud of. If you look at the original boards, we do have this scribble that says that there is a zero CO2 footprint, because we do care a lot about all the manufacturing of those boards, and we try to use manufacturing procedures that do have a very little footprint. Of course, electronic components are something that have an impact on the whole world, because there are some substances that are used into components that are creating problems. So what we decided is we are using components that are not impacting on these aspects in the true environmental sense of the word. And on the other side, we try to make our boards with the lesser impact possible.
And as opposed to, say, a single board computer, this is like probably taking up a lot less power and a lot less than that. So to some extent, would you say that's correct?
Well, I would say that...
I know it's completely different things.
Yeah, completely different things. Basically, if you go to a very low power Arduino and you just need to transmit scattered IoT data here and there, you could even have an Arduino with a solar cell and a battery, and you can really
with
get...
a solar cell. Oh.
Yeah, solar cell. But the point is that you need sun, and also the production of the solar cell has got some kind of footprint in terms of impact on...
So it's a very complex equation when you get into it, but you can obviously see you guys are doing your best.
Yes.
Okay, so should we go on to the swag?
Well, I think that we finally can say who are
going. We had a couple of answers that were not answered. So a couple of questions that were not answered. But that's a good challenge. I think people can then maybe try for the certification, because these questions are all from the certification.
Exactly, and this is something very interesting. Everybody is, an Arduino expert, but when it goes to helping other people or maybe teaching, doing workshops, might be nice that you challenge yourself and see if you're really into Arduino and you know what you should know in terms of programming, hardware, the IDE, the various aspects. And this is what we're addressing with the Arduino certification program. So if you want to feel better and say, yeah, I'm a little Arduino expert, try our certification program. And you also get a very nice certificate that is something that people can check, because there is a QR code and you get a unique identifier, so people can verify that your name is in the database of the certified Arduino people.
Well, no, that's great. Let's get on to the swag giveaway. But before we do that, I just want to say thank you to, was it Christina, I think?
Yes, Christina. And all the friends we've got in Turin that made, also, we have got a whole team of people in Turin working to manage this Arduino Day thing that really was like, it was supposed to be one way, and then...
Well, we got the swag way back.
Yes.
Obviously before, when we were still doing like an in-person event, and we were prepared for a lot of different things. And then, we wanted to make sure that we didn't miss Arduino. It's a big birthday, 15 years. It's.
Yes.
I would not, if somebody asked me off the top of my head, I would not say 15 years, but that's really good. That's a big milestone.
Yeah, and by the way, for technology, 15 years is a lot of time, because in 15 years...
2005,
Yeah, 2005, and in 15 years...
There's no was there Facebook? It was just there.
Yeah, well, but so many things happen in 15 years that you probably... Well, first of all, we are all using smartphones and WhatsApp and this kind of communication means in a way that was really unprecedented. Also, this Internet of Things phenomenon is making things happening much faster than expected. And there is also this thing of the machine learning. Our new little boards, the Arduino Nano BLE and BLE Sense, are capable of doing and executing machine learning. When Massimo designed the first, Arduino board, he probably didn't imagine that his boards would have been able to run machine learning application on them. Yeah. So that's quite something.
That's amazing. Please do convey our regards to Massimo and congratulate him from our side, from the assembly.
We are going to see him in
a little while.
In 3 hours.
So for those of you who don't know, Arduino is also doing a live stream, and that's the main live stream, and we're going to make a little guest appearance there as well. So we're going to speak to him there. So do check out that. We will post details of how it happens. We will show you. We will share that on social media.
You can go on to the day.arduino.cc. That is the website for the Arduino Day. And there is already probably started. It's probably starting.
Still a while.
No, because it's starting at 11 their time. So
11 their time. So which is now. Okay, so it must be starting right now.
Right now. So the stream goes on.
Okay, I think we've kept everyone waiting long enough about the swag. We wanted to just get all the things. Again, thank you to Arduino. Thank you to Simone. Let's go straight to the swag. So the following people should contact us. I'm going to read out the names and you can sit on.
By the way, we have got their emails because you sent in emails, so we are going to be able to contact you.
We've got all the emails, but I'm going to obviously read out just the names. You can see the names on your screen also. So we have Hamad Khoury, we have Nigel Nitin, Samer Al Rehavi, V. Nagendra Babu, Jin Saito, Amar Ali, Marwan Salah, Nitin Tharian, and there's also somebody who just sent their name in as Leo, but we know their email address, so we will definitely get you your swag. You do have to, we will keep it here, and you can definitely get in touch with us as soon as possible if you see your name on that list. Okay, thank you all for participating. It was a fun little thing. We don't have, we want to, there are lots of things we couldn't do, but this is something that we definitely could do owing to the situation, and it's important to keep things normal also, right? So I just wanted at this point, apart from Simone, I'd also like to thank our team, our skeleton team. We've been working, you saw a lot of the people who came online, they were all remotely because we don't, as a matter of policy at the lab, we are not keeping any of our interns, and we just have a skeleton crew. So we have Saleh and we have Rahul, our lab manager who you met earlier, who is the genius with all the streaming stuff and the production of all the videos. So he's been instrumental in that. So I just want to thank him. And we will come back to you with lots of content. I mean, the assembly is right now on hiatus from live meetings, from like in-person meetings, but we are going to be doing live workshops every week. And we are also going to post, whenever we do a live workshop, we're also going to post it in an archive so you can follow it, anything. We will be doing a lot more content, and we will share this content as well. We will kind of package it a bit, and you'll see a lot of it. So please do go over it again. There's a wealth of information from Simone, and we definitely want to go on that. Can we go to the last slide? And then just want to say that with voice. Okay. So it just leaves us to say thank you. You can't see our face right now. We will come back to that. But I just wanted to say thank you to everyone who followed along. This was a really special event given the circumstances, and we're happy that we were able to execute it. And of course, finally, a big thank you to Simone. I'm going to keep coming back to that because we're very lucky to have that, and I don't think many other places would have a resident Arduino maker who could do on that. So can we come back to the live view?
Yeah. Thank you everybody. Thank you for your time. Thank you for the passion you put every day in using the Arduino boards. Let's keep in touch. Let's keep making this a better place locally and globally. Don't forget that the Arduino community is also active on these COVID things. There are forums working.
I saw that the respirators.
Yeah, there are friends in Spain that are working on the respiratory support. And again, of course, just consider that when it's a matter of health, be very careful. And indeed, there has been an initial kind of spread of nice ideas, but people are now getting back to the real stuff. So things have to be done properly. We'll be looking into that. We are calling experts that will certify the equipment. And again, is being very quick, being creative, but also be very careful.
Of course.
Take care, everybody.
Take care.
Bye. Thank you very much.